This is IAT lecture 1.5, and today's topic is Java syntax and semantics. So what does that mean? So the overview for today is syntax and semantics. What does it mean? Pardon the pun there. And we're going to then talk about Java syntax, variables, and types. These are the elements of things that you need to use in Java and other programming languages. And finally, we'll talk about printing variables, printing values. So first, in the pieces of code that I've shown you so far, let me just briefly go to the captured window here. In the previous lecture segment, remember that we had written this little program of clearing the background, drawing a bunch of points, a line, a triangle, setting the stroke and rectangle and ellipse and so on. As you keep writing code like this, you may reach a point at which you kind of forget what you were thinking as you were doing it. For my purposes for this lecture in the previous segment, I was just writing some code in order to demonstrate the capabilities of computer graphics. However, as you are writing programs, you may write so much stuff that you forget what you were doing or forget why you were doing it. And so I'd like to point out a very important element of just about every programming language and most scripting languages is the comment. So comments are non-program text you put in a file to describe to others and to yourself later what you're doing, what you were thinking when you were writing that code. Sometimes the purpose of a comment is for you to document inside the code the thought process that is going on about the algorithm that you are encoding in the piece of code that you wrote. Other times, its purpose is for you to say that there's an important part of your thinking as you write and rewrite and evolve the code that you've got. The purpose of the comment is to tell you what your state of mind is as you wrote this code. You may then continue to write some code, and you can also use comments to specify to the Java compiler, this piece of code in between these comments is to be ignored by the compiler. And that's a very common and important use of comments. So let's say how a comment works. Single line comments begin with, as shown in red here, double slash. That is to say a forward slash followed by another forward slash or slash. Everything that follows on that line of text is treated as a comment and is therefore ignored by the compiler. And you as a reader of code will get used to noticing that double slash means comments. You can start multi-line comments by starting a comment with slash star and ending that comment with star slash. So if this were a piece of Java code, this entire slide, whatever is from this point forward to the end would be ignored by the compiler. And the compiler will pay attention to this part and then ignore everything from here through to there, between the slash star and the star slash. So as I said just a moment ago, commenting and uncommenting lines is useful for figuring out code. In particular, if you have a piece of code that you just added and it's causing some kind of error, it can be valuable to put comments around that chunk you just added to verify that the other stuff you had written earlier works properly. Okay, so let's move forward. So I have been mentioning the word syntax a few times, just kind of in passing without really defining what the word syntax means, and now's the time to define it. So syntax is the study of the principles and rules for constructing sentences in natural languages, and you may have taken courses in syntax during your elementary school and high school days. In computer languages, syntax is also a thing. Computer languages are formal languages. That is to say, unlike human languages that people speak to each other, formal languages have strict rules for well-formed statements. And the rules are so well defined that a machine can evaluate those rules and specify when those rules are not followed. So well-defined meaning for well-formed statements is what goes on in computer programming languages. So computer languages are formal languages that have strict rules for well-formed statements. That means if you write your code correctly that follows the syntax rules, then your machine will interpret the correctly formulated code correctly. Now, that does not mean that the code you wrote does what you were thinking, but if it follows the syntax rules, it does what you said. There's an important distinction there, which we'll get to in a minute. So syntax is about formulating code correctly. That is to say, formulating it such that it doesn't give you little errors as you type. Semantics is about the meaning of well-formed statements. What does it mean to say that we issue this call, POINT, open parenthesis, two numeric values separated by commas? So as we move forward in the term, we will talk about correct syntax, which I'd shown in the previous lecture segment. We will describe the basic semantics. So, for example, in the previous thing, a line call with 4 parameters draws a line segment. And we will explore also the use of these tools for design. And we didn't really talk about design in the previous lecture segment. We were just interested in describing what basic primitive graphics capabilities are available within processing. So, syntax, semantics, and how to use it. That's really what I mean by design here. Not about design in the larger sense, about balancing desirable qualities and things like that. We're talking about the basic how to use these tools and techniques. So, in the drawing primitives that we spoke of in the previous segment, let's just go through what are the different syntax parts of those drawing primitives. So here we have an example of the line call, and this thing here is a specification of a call to a procedure that is present elsewhere within the processing system. The name of that procedure is, not surprisingly, line. And we know it's a procedure because it has immediately after the name of the procedure is a left parenthesis or an open parenthesis, and after it is a closed parenthesis and a semicolon. Within those two parentheses are a set of, in this case, 4 parameters, or also known as arguments. And here there are 4 numbers, some actual numbers, 0, 0, 50, and 50, which specify the x and y locations of one endpoint and the x and y location of the opposite endpoint of this line segment. So what these parentheses do is specify to the programming language what the parameters are and where they are to be found. This thing over here is the name of the procedure, as I mentioned. It is also known in object-oriented terminology as the name of the method. That is to say, the name of the piece of activity that is going to be run, and that activity is named line, in this case, for drawing a line segment. And at the end is this syntax element that says, which is the semicolon, and its purpose is to terminate the specification of this thing, so that you can then, the compiler can then start interpreting whatever follows the semicolon, typically something on the next line of text, that will be a new method call or something else. So most of those drawing commands that I showed you previously, each of those things are methods within the graphics library of processing. Methods are reusable commands. It's a little machine that does this work for you. It's specified clearly as to what it does and how it works. And the purpose of that is that it lets you reuse a piece of code that somebody else wrote without you having to type it over and over. That is to say, you as a user of the computer graphics library don't have to figure out how to draw lines. Obviously, the machinery knows how to do it. The processing system knows quote unquote, how to do it. And by issuing the line call and giving the 2 endpoints, it does it and you're happy. The arguments of a method call tell the method precisely what to do and where to do it. And we'll see later that you can define your own methods. And in fact, that's what the bulk of the rest of the course is going to be about, is defining your own methods, organizing the collections of methods, and so on. The other thing that's very important in all computer graphics, all computer programs, are variables. We hadn't really dealt with variables so far in the computer graphics examples. We just simply used hard-coded values, 0, 50, 85, 75, etc. So what's a variable? A variable is a named box, speaking metaphorically, for storing a value. You can put values in a variable by using the assignment operator. And the assignment operator is the single equal sign. On the left is the name of the variable to which you wish to assign a value. The equal sign then follows, and the thing to the right is the value that you want to assign to that variable. So there's the value, there's the variable. And it is terminated, once again, with a semicolon. Now, this is the simplest kind of assignment that you can do, is to assign a variable with some constant value. So if you want to use the value of that variable, you just simply use it in the place where we used a constant value. So here we go. To use the value stored in a variable, just use the variable's name. So assign the value 1 to x, and now just use it line x0, 50, 50, and that would put a line segment that goes from 1, 0 to 50, 50. And anytime you want to use that x value, you just put the variable x where you would expect any other kind of value. All variables in Java and in processing have a type, and Java is a kind of language in which you must specify the type in advance. There are other programming languages, JavaScript it being one of them, where you don't have to do that. Those languages use a very sophisticated type inferencing method to figure out what the type should be. Java's design decision was not to go that way. Instead, the designers of Java said, you need to specify in advance what the type of everything is. The advantage of doing that is that you know what you're getting every time you create a variable. The disadvantage is the burden of having to specify. So we're using Java within the processing system, and that means all the variables that you want to use, you have to tell in advance the processing system what the type of that variable is. And you specify the type first. So here we show an example of giving a variable a type by specifying its type and then what the variable name is that you want to declare. So here we see int x, and what that is saying is that x is of type integer. Int is an abbreviation that's used throughout Java and C and other types of languages. It's short for, it saves you from having to type the whole word integer. Anyway, int x and int y, what we've done here in this piece of code is specify that x is an integer and y is an integer. Note something very important. At this point, neither x or y have yet had their values defined. We've just said what type they are, and we haven't said any more. And these next two lines do specify what the values are. We say x equals 20, and what that does, I'm telling in the comment, store at 20 in x and store 30 in the value y. If we were to then issue the call point xy, this would then draw a point at x equals 20, y equals 30. So far straightforward. And in this little snippet of code, it seems pretty redundant. If you want to draw a point at 2030, then just say point 2030. But what I'm doing here is illustrating the point of variable declaration, which is the first two, to declare what the types are, and variable definition, which is to say what the initial values are. Behind the scenes, I'm showing kind of an approximate picture of what happens. When you're creating an int variable, what happens is that Java behind the scenes reserves a small piece of storage to store sufficient memory to store a single integer. There's an upper limit to the size of that integer. It's probably 64 bits. And to declare a variable, say an int, that's the name, it goes off to the back room and stores and finds a piece of storage and reserves that for future use and puts the name on it, an int. When I then assign the value 3 to that AND int, the value 3 is assigned to that piece of memory. One of the things that declaring the type in advance permits you to do is it permits you as a programmer to detect errors where you assign the wrong kind of thing, something that isn't an integer, to the variable that you've already declared. And I'm intentionally giving you an erroneous piece of code here. So we said int and int equals 3, and then again and int equals quotes hello. PowerPoint sort of goofed me up here with these double quotes. But what that does is that creates a syntax error because it's a type error rather, which means that we're trying to assign an incompatible type. That is to say, hello being a string is not an integer, and therefore we cannot put it in there. Within Java, assigned values must match the type. Java doesn't allow the programmer to make types up as you go along. You have to specify the type in advance, and you have to go along with your specification. So here we say int x, int y. It says that those two hold only integers. When we say x equals 1.5, 1.5 is not an integer. It's a real number, or a floating point number, as it's known in Java. And this would cause an error because there's a type mismatch between this thing here, the floating point value, and x, which is an integer. So that then begets the question, why do we have types at all? Well, one of the reasons why we have types is that it tells the system, and you, the programmer, and your teammates, if you have some, what kind of values to expect. And the system uses types to detect errors. And typically, these errors don't crop up so much when the programs are small, the size that we've been showing in the processing window. It's when the programs get big, and you might sort of forget what you did last week as you were building a large program, that errors of the kind shown here crop up. So here we're showing an example of, say, int pi. We're declaring this variable as an integer, pi, and we're assigning it 3.14. And so the concept here perhaps is that this is pi, the transcendental number. But the error here is that the type specification comes first. And because we specified this, that the pi here is an int, this assignment of 3.14 doesn't work. It creates a type mismatch error, and that's wrong. So what this is doing is it's using the machinery of types to tell you as a programmer, oops, you made a mistake. There's an inconsistency with your thinking. Now, the Java compiler is utterly incapable of telling you what the inconsistency is. It's only capable of telling you that there is an inconsistency, and the mechanism of it being able to do that is just simply the type mismatch, and some other things which we'll talk about later. So I mentioned earlier that there are a number of types. There are a number of primitive types, and they're called that because there's a very direct correspondence to the types in Java and the fundamental types that are supported by the absolute basic machinery of the computer system. So those types are int, which holds integers between -2 billion and +2 billion or thereabouts. Real numbers, designated as float or floating point numbers, and they're numbers with fractional parts, as you can see here. Here's an approximation of pi, 3.1415927, etc., -2.34. And floating point numbers have a much larger range, but not perfect accuracy, whereas you don't have that problem with representation with integers. Char, or characters, can hold a single character. Byte holds little integers between -128 and 127. As you might imagine, those are 8-bit quantities. The int here is a 32-bit quantity. And something that is special for Java is this type Boolean, and it holds only two values, true or false, and spelled out like this, although not in italics. Processing has another type built into the processing system, but it's not actually part of Java, which is color. and it is actually behind the scenes a 4-byte value or an unsigned integer value. It's a convenience type for compactly representing color within the processing system. And it has this name color that you can use as a type. As I showed briefly in the 2 slides ago, you can combine declaring, that is to say, what is the type, and assigning, that is to say, setting its initial value. And you see this all over the place in Java programs and in processing programs. So you can declare means tell a variable, and that is means telling what the type is, int x once again. And the first assignment of x to some value is initializing or assigning a value. You can combine these in a single line. So int x equals 1, y equals 2. And the fact that they're all together on this line, int x equals 1, indicates that x will start with a known value, and y will also start with a known value, x being 1 and y equals 2. You can only declare a variable once, however. If you were to have a second statement, int x again, it will create an error because you can only declare a variable of whatever of any name one time. That is to say, once you've used a name, you can't reuse it within the particular scope of the program's code. And we'll talk about scope as we move forward. So declare a variable only once, otherwise you'll get an error. Finally, let's talk about when we're dealing with variables, it's often useful to be able to find out what values your variables have. And I have found over 30 or 40 years of experience that the best way to find out what your variable values are is to print them out. In the processing system, that, of course, let me just switch over, those printouts show up here in this, in the black debug area, in the console area. Let me go back to those slides. The print and print line print to the bottom of the processing pane in that console area. They do the same thing in terms of generating output into the console. Print line just simply terminates whatever you're asked to print with a new line so that whatever follows is printed on the next line. If you say print and then later on print, the first print will be followed immediately by whatever you asked for in the second print. Okay. So that wraps it up for Java syntax and semantics, and it's just a brief introduction as to variables and the syntax and semantic rules of Java.